So now we're looking on the sp hybridization, how sp hybridization happen and what kind of molecule have the sp hybridization and what are the other properties we need to know. So in case of sp hybridization, you can get the idea from the name sp. So one s orbital and one p orbital mixed together to give you the sp hybridization. And remember, there should be outer shell mixing, not like 1s. It should be 2s 2p, something like this. So if we take like 2s and 2px, so these two orbital mix together, and since they are two orbital mixing, so you will get two equal new orbital. So each orbital will be called sp, because s and p mixed. And remember that here one s orbital, one p orbital. So what is the s character? Yeah, you are correct. 50% s and 50% p. So 50% s character, 50% p character. So now think from the sp3, like s character is 25% and sp2 s character was 33%, and now sp s character is 50%. So as the s character increasing, electron have tendency to stay closer to the nucleus. So in that case, the carbon hydrogen for the sp3, like for the methane carbon hydrogen bond and carbon hydrogen double bond and carbon triple bond, so that bond length gets shorter as you go down, like sp3 sp2 sp, because electron density want to stay like close to the center, because s character is more, because s character is a spherical, you remember that, and p orbital like dumbbell shape. So that is one thing. And also for the increase of s character, the acidity of the bonded carbon increased, like you can easily remove by using some kind of base like ammonium hydroxide or like cuprate solution, ammonium cuprate solution, those kind of things. Like you can easily remove hydrogen. There are lots of chemistry I will discuss in my next any other video. So so that's the thing. Just you can remember, like s character is decreasing as you go down for the sp3 to sp2 and sp. So now you have like new two orbital sp they are equal energy and both of them has one single electron in it. So now if we draw the sp carbon, how it looks like and how it formed the bond. So in that case, see, you can show this like a small dumbbell here anyway. So this is the sp carbon. So in sp carbon, angle between one bond to another bond is 180 degree. Okay, and once it has formed, so one hydrogen come here, so one electron from the hydrogen, one electron from here make double bond, like so it is a sigma, it forms a sigma bond. So we can think this is a sigma bond, carbon hydrogen sigma bond. So like if we mimic like this, so this is a sigma bond, and we can say what kind of sigma bond? sp s sigma bond. So we can say s sp sigma bond. And here another carbon, when similar kind of another carbon come here, and here one hydrogen come with one bond, one electron. So this carbon form another carbon, another sigma bond. So it is sigma bond. And what kind of sigma bond? We can say sps sigma bond. Okay, now here it is forming one sigma bond, so we can say sp sigma bond. So in case of sp hybridization molecule or like triple bonded molecule, it has one sp sigma bond, one sps sigma, like two sps sigma bond in the side. Okay, so when it is connected, so we can directly attach this as a sigma bond. But now we are going to erase this part to explain the remaining part, because we have like unhybridized orbital. So if you see, it was mixed 2s 2px, but we have unhybridized 2py and 2pz. So let's see how it looks like. So we can say so if we say this is the py and this is the py unhybridized part, and this is the pz and this is the pz, this is another unhybridized. So when they're like unhybridized, p and p can do one partial overlap, so we can say this is partial overlap. So this is one pi bond, okay? And also pz and that pz so another pi bond. So there are two pi bond. So one carbon-carbon, one sigma bond, two pi bond. So in like that means the sp happen only for the molecule where carbon-carbon triple bond, like when it has one carbon-carbon single bond and additional pi bond. So one pi, another pi, and one sigma. So only for triple bonded molecule you will see the sp hybridization. So in this case, this partial overlap of this pi orbital, it can form like a cylinder shape, like those pi electron can rotate through the central carbon. So that's why we can draw this molecule in different way, and that pi electron actually called cylindrically shaped. So suppose you can think of this is a carbon and this is a cylinder and this is another carbon. So you can think of like this pi electron are rotating through an axis. So this axis is like this hydrogen, carbon, hydrogen, carbon, hydrogen. So this is like, you can think this cylinder is rotating. So let's see with the molecular kit how it looks like. So this is the sp, this carbon is sp, this carbon is sp, and sp as sigma bond, and this is sp as sigma bond. And if you see all three different way, like it like a cylindrical shape, like since it is like kind of wet type, that's why you may not understand how it is cylindrically, but imagine all are like rotating the same phase, like as an electron cloud. So it is like a cylinder shape. So originally the sp like ethylene molecule, sorry, acetylene molecule or ethyne molecule is like this, like triple bonded this compound. So this is formed by the sp hybridization. So okay, so if you have any question on hybridization on sp3, sp2, and sp, you can ask me in the comment. I will try to answer my best. Thank you for watching my video, and if you didn't subscribe my channel, please do it, and whoever already have done, thank you for supporting. Bye now.